Hello everybody, so we are going to move on today. I know that some of you were struggling with this like simplifying part, but if you have further questions, please let me know. I can get on a Zoom conference with you. We can do whatever we need to do just to get you to where you need to be. But I can't help if I don't know. So right now I've been doing Zoom conferences, but nobody's been getting on. I stay on for like 30 minutes and nobody hops on. So I'm not going to keep doing them if nobody wants them, but if you feel like you don't know what's going on, please get on there. Ask me questions. We can go problem by problem. I can share my screen with you and do problems with you. I can bring up a whiteboard and do problems with you. Whatever we need to do just to get you to where you need to be. So you are going to get more practice with simplifying things when we do this next step. But I want to start by adding and subtracting radicals. So that's what you see on this page here is just the adding and subtracting of radical functions. So we're going to do these notes and then I'll have 4 problems for you to submit to me today. So starting off, just like everything that we've done so far, we do have some things that we need to keep in mind when we're doing this. So the first thing is that we need to simplify all of our radicals. All of our radicals need to be in that simplest form that they can be. So that's just like what we have been doing, where we've been breaking the radicals down and making them into their simplest form. So the next thing that we need to do is identify radicals with the same index. So that means things that are both square roots, cubic roots, fourth roots, and that's just as high as we're going to go. So anything, they need to have the same index. So they both need to be square roots, they both need to be cubic roots, or they both need to be fourth roots. Those are the only things that we can add and subtract. The second thing that needs to be the same is the radicand. So all the numbers underneath of that radical symbol need to be the same. So a way that you can think of this is like terms. So you wouldn't add an x and a y because they're not the same variable, but you could add an x and an x. That's the same concept here. The numbers underneath the radical need to be the same in order to add or subtract them. And that's only then that they can be combined. Just like we combine our like terms, they have to be the same thing for the radicals. So for common radicals, we can add and subtract the coefficients. So adding and subtracting the coefficients means adding or subtracting those numbers in front of the radicals. So our numbers in front of the radicals, we can add or subtract those, and then we keep the radical underneath the same. So that'll make a little bit more sense when we go into some of the examples that we have here. So let's just dive right in, get right in there, and see what we are working with. So just like our first step said, I'm going to use a different green. Where are all my colors? Okay, perfect. So just like our first step said, we need to simplify all of our radicals. So right now, these are both square roots, which is cool, but 27 can be broken down further, and so can 12. So we need to break 27 into the square root of 9 and the square root of 3. And keep in mind, we still do have that 3 out front, so we need to bring that down as well. Now, when we continue simplifying, we know that the square root of 9 is 3. We don't know what the square root of 3 is, so we keep that guy. So we have 3 times 3, the square root of 3. So when we break that down further, that means that we have 9, the square root of 3. So all I did there was simplify that 3, the square root of 27, and I broke it down into 9, the square root of 3. We can do the same thing here with 2 radical 12. So radical 12 can be broken down into the square root of 4 and the square root of 3. We still have that 2 out front. The square root of 4 is 2. Bring down that 2 from out front. And then radical 3 can't be simplified, so we have the square root of 3. So when we combine those two front numbers, we get 2 times 2, which is 4, and above it said that we were subtracting, so we have 9 radical 3 minus 4 radical 3. And then we said that the index needed to be the same and the radicand needed to be the same in order to combine things. So our index here is both 2. These are both square roots, which is great. Check off of our list. Same radicand. That means that this number and this number need to be the same, which they are. So even better. So that means that we can go ahead and add. So in order to add, I'm going to keep these underlined, sorry. So in order to add, we need to add or subtract the coefficients and keep the common radicals. So that means we're going to do 9 and 4. We're going to do that addition with 9 and 4. So 9 minus 4 is 5, and we keep whatever our radical is. So 5, the square root of 3 is our answer. So I'm just going to talk through that one more time. All we did was simplify our radicals there in green. I identified that they had the same index and same radicand. And then I added or subtracted my coefficients. And then in this case, I subtracted my coefficients. So I did 9 minus 4 to get that 5. And then the radical stays the same. Nothing happens to that number underneath of the radical. So if we keep going, and if I do number 2, I am going to skip some of the simplification steps just because I believe that you guys can do that. And this is kind of a small box for me to write in with my little pen. So just kind of bear with me there. So this first one can be broken down into 3 times the cubic root of 27 times the cubic root of 2. And then this middle term is going to stay the same. So this guy is going to stay the same. We can't break that down any further. But the last one is going to break into 7 times the cubic root of negative 8 times the cubic root of 2. And then if we keep simplifying, we're going to end up with 9, the cubic root of 2. Minus 2, the cubic root of 2, minus, because it'll be negative 2 times 7, which is negative 14, the cubic root of 2. So then we're going to check that they all have the same index, which they do, cubic root, cubic root, cubic root. And then we're going to check our radicands. So we have a 2, a 2, and a 2. Those are all the same. So that means that I can go ahead and do my addition and subtraction. So again, when we do this, we're going to use our coefficients. So our numbers out front. So I'm going to do 9 minus 2 is 7. And then 7 minus 14 is negative 7. And we keep that cubic root of 2. So we keep everything else the same here. So we simplified. We made sure we had the same index and the same radicand. And then we just simplified again. We combined our like things. So if we continue in this fashion, 7, the fourth root of 48 can be simplified into 14, the fourth root of 3. I'm just skipping the simplification. But if you need to see that further, please let me know and I can kind of go over that with you guys. Negative 2, the fourth root of 3 cannot be simplified. So I'm going to just keep that guy the same. And then 3, the cubic root of 72 can be simplified into 6, the cubic root of 9. All right, so from here, we're going to check our indexes. So we have a 4 and a 4 and a 3. So those guys cannot be combined. So we only have 2 that are able to be combined, and the last one will not be able to be because it's not also a 4. Then we're going to check our radicands. So we have a 3 and a 3. So those guys can be combined, which is perfect. Last step, we just look at the ones that we can combine. So that's 14 and negative 2. So 14 minus 2 gives me 12 on the outside. Everything else stays the same. And we couldn't combine anything with that cubic root, so we just rewrite it. So our final answer is 12, the fourth root of 3, plus 6, the cubic root of 9. I'm going to do 3 more with you guys, and then you'll have 4 on your own. So if I continue over here, 10, the square root of 28 can be simplified to be 20 radical 7. And then this cubic root of negative 56 can be simplified to negative 2, the cubic root of 7. And negative 4, the square root of 175, can be simplified to negative 20, the square root of 7. So this one's a little bit more interesting. If you look, we have square root, cube root, square root. So we can't do anything with this guy. And then we need to check our radicands. So we have a 7 and a 7. Perfect. That means I can combine those outside too. So when I do so, when I combine this guy with my last guy, those end up canceling each other out. So when I add the two, when I do 20 minus 20, I get 0. So those guys cancel each other out, and I no longer have these. So what I'm left with is just this negative 2, the cubic root of 7 for my answer. All right, so now let's add some variables into the play. Nothing else changes. Everything else stays the same. So don't get too worked up about it. Everything's going to be all right. So I am going to break this down a little bit more. So when I break apart that 98, that breaks down into 49 and 2. So I have the square root of 49 and the square root of 2. So I know what that is. That's 7. And then I need to look at my variables. So I have 2 groups of 2 in x to the 4th. So we're looking at a squared root. So I need to think about how many groups of 2 are in that variable. So since there's 2, I'm going to have x squared on the outside. How many groups of 2 fit into that y squared? Well, just 1. So we're going to have a y on the outside. And then nothing else can change. That square root of 2 is going to stay. So if I look at my other, what I'm subtracting by, I can't simplify that at all. So nothing's going to happen. I'm just going to rewrite that. All right, then we're going to identify our index. Our index here is 2, and our radicand is 2. So we have both square roots, and both of our numbers underneath of that symbol are 2. So I can go ahead and add the outside. So what I'm going to make sure is that these two have the same variables as well. So we have the same numbers, and then x squared, y, and y. So I can actually add those. So I'm going to do 7 minus 3. I'm going to get 4 x squared y, the square root of 2. So remember that when we add or subtract anything with variables in it, nothing happens to the variables. It's just the coefficients out front. Same thing here. All right, so if we move on to this last problem here, the cubic root of negative 40a to the 7th plus 2a squared, the cubic root of 135a to the 4th. So negative 40, I can break into the cubic root of negative 8 and the cubic root of 5. So if I just go from there, the cubic root of negative 8 is negative 2. I need to look at my variable and think, how many groups of 3 go into 7? How many groups of 3 go into 7? So my answer here is 2. So I'm going to have a squared, and then nothing happens with that cubic root of 5. So we're going to leave that guy in. And then if I have 2 groups of 3 inside of 7, I have to think how many are left over. Well, that's just 1. So that's my simplified cubic root of negative 40a to the 7th. If I simplify the other section, so we still have that 2a squared on the outside. 135a to the 4th. I need to think about what are the perfect cubes that go into that. So one of them is 27 and the other one is 5. So the perfect cube is 27. So this guy becomes 3. So I'm going to have, I'm going to put my little plus here. So 2a squared times 3. And then I also need to think about how many a's are going to come out. So how many groups of 3 can go into 4? Well, that's only 1. So just 1a is going to come out. And then cubic root of 5 is going to stay. And if I took out one group of 3 from that a to the 4th, I'm going to have 1a left over. My last step here is to just combine my information. So I'm going to do this in purple. I'm just going to combine these two. So I'll have negative 2a squared times the cubic root of 5a plus 6a to the 3rd times the cubic root of 5a. And then I'm going to look at my index, which are both 3. I'm going to look at my radicand, which are both 5a. But when I look at this, my coefficients, I can't combine those. Those coefficients are not like terms. So we don't have to combine anything. We are going to leave it just like this. So this is my final answer. So all we covered today was adding and subtracting radicals. So we simplify, we make sure they have the same index and same radicand, and then we add or subtract whatever is on the outside. I am going to post a copy of these notes along with your assignment, but I will show you down below here what it's going to be. So your assignment for today is going to be number 1, number 2, that was a bad line, number 2, number 3, and number 4. So you only have 4 problems to do. If it goes well, we'll move on. If not, I feel like we're going to spend a couple days on this just because this is kind of a harder concept to teach, especially over technology as we are right now. So just hang in with me. Let me know if you would like me to do a Zoom conference today. So I will post that. I have that posted in this module as well. Just let me know via message, like email, or if you want to shoot me a message on Instagram, whatever. Just let me know if you need to do a Zoom conference today with me, and I can hop on and we can talk about how to go about solving these. If you have any other questions, please shoot me a message and let me know.